Okay, hi all. For today's lesson we're going to look at finding the length of the side of a right angle triangle. So finding the length of a side. So today we're going to put together a few of the things that we did in the last few classes. And I've said previously that really these questions, they're all what we're heading towards is finding the lengths of the sides of triangles and finding the measure of angles in triangles. Now we're going to leave the angles for today and just concentrate on finding the lengths of triangle sides. So I have three questions here that we're going to go through. The first one is, you're given this right angle triangle. It shows where the right angle is. You're given this angle, the size of this angle. You're given the length of this side. I'm going to leave out units, so centimeters or millimeters or whatever, and just have it as 12. And you're asked to find the length of this side over here, and they've called it x, or I've called it x, so that you can try to use that variable name to work it out. Okay, so here's what we're going to do each time. Each time, if they describe this in words to you, you will always draw a sketch. Look at the way I've done it here. No ruler involved, just a quick sketch, that's all. And put in all of the information that we know. In this case, you were given the drawing, but in other cases, they may just describe a right angle triangle with one side x and one side 12, etc. So always draw a sketch anyway in these cases. The next thing you're always going to do with these when it comes to trigonometry is label the sides of the angles. So, if this is the right angle here, this must be the hypotenuse across from it. If this is the angle we're going to be dealing with, this is the only angle we know, even though we could work this one out very easily because we know the three angles in a triangle sum to 180, but we won't bother for now because we don't need to. So if this is the angle we're dealing with, then this side is the opposite, and this side down here must be the adjacent. So, step one always, draw a sketch of the triangle if you're not given one. Step two is always then label the sides of the triangle. Okay, the next thing we're going to do, and I will write these steps in notes for you to add to your notes copy also, so don't worry about writing this down at the moment, just watch it. So the next thing we're going to do is we're going to pick which one of these ratios is the one we're going to use to solve this problem, either the sine, the cos, or the tan ratio. Okay, and the way we do that depends on the information that we have here. So what we look at is, we look at our triangle, we look at the length of the side that we have, because we'll have the length of one of our sides always, so in this case it's the hypotenuse. We look at the one that we're looking for, in this case we're trying to find the length of the opposite, and we then, if I draw a circle around this, hypotenuse, opposite, then we try and pick a ratio that has both the hypotenuse and the opposite in it. We always ignore this one that doesn't have an x or doesn't have a number next to it. So if we look at our 3 here, the only one of our 3 ratios that has the opposite and the hypotenuse included in it is sine. So we're going to pick sine as the ratio we're going to use. So sine. Then we're going to put it as sine 53 degrees, because this is the angle that we've been given, sine 53 degrees, is equal to. So we can find what sine 53 degrees is using our calculator, so that's great. But we also know that sine of that angle is equal to opposite over hypotenuse. So we can put it equal to opposite x over hypotenuse 12. X over 12. And what we've done there is we've formed a linear equation with one unknown. So we're very good at solving these linear equations, so it's no problem to us then to solve this equation and find the value of our unknown x. So what we're going to do here is, to solve it, we're going to multiply both sides by 12 to get rid of the fraction on this side, and we end up with 12 times sine 53, and this is how we write it when we're multiplying a number by one of these ratios. We don't have to put it in brackets. We can put it in brackets if we want, but we don't have to. Is equal to x. If I multiply this side by 12, I get x. And then the next step is really just to put that into your calculator and find the value of x. And so again, make sure your calculator says d at the top, and if it does, we're ready to go. So what do? We want to find what 12 sine 53 is. So it's just 12 sine, the calculator knows it means 12 multiplied by sine 53, 53, close my brackets, equals 9.58. I'm going to round it off to 2 decimal places. So x is equal to 9.58. Okay, I'm going to do it a little bit more quickly in this one. So again, We've got our sketch, so we don't need to do the sketching part, this first step. The second step is to label. If that's the right angle, then this is the hypotenuse. If this is the angle that we've been given here, then this must be the opposite, and this must be the adjacent. That's step 2 done. Step 3 is to decide which one of our sine, cos, or tan we're going to use, and we decide by ignoring the one that we don't have an x for or we don't have a number for. So again, we're going to use the opposite and hypotenuse. So it's actually the same as the first example where we're going to use sine. Sine. Now we're going to say sine of this angle, 45 degrees, which we can calculate using our calculators, is equal to, well, we know from the ratio, it's opposite over hypotenuse, so 14 over x. And so it's slightly different this time because this time the x is on the bottom. But we have no problem with that. It'll just take an extra step. We'll multiply both sides by x to get rid of the fraction on this side, and it gives me x sine 45 degrees equal to 14 over on this side. And then, since we don't want the sine 45, we'll divide both sides by sine 45. So x is equal to 14 over sine 45. And again, we have no problem putting that into our calculator and finding it. Our calculator will do all the heavy lifting for us. So we want to know what 14 over sine 45 is. So 14 on top, and on the bottom whereas sine 45. Now, just as an example, I'm going to show you, because I mentioned earlier that sometimes if you leave the brackets out, it will give you an error. And I'd say this is one of those cases. Yes, it is indeed. So if you ever get something like that, just check again to see if you've got the brackets where it should be. So closing that bracket, 14 over sine 45 gives you 14 root 2. And I suppose if we do it like our first one and look for our answer to 2 decimal places, that's 19 point. And if we round that off, it'll be 80. 19.80. Okay, one more time then. So again, sketch drawn, so that's the first part already done. Second part is label. If that's the right angle, this is the hypotenuse. Okay, if this is the angle we're given, then opposite to that is this side, and adjacent to that side is this, or to that angle rather, is this side. And so then we decide which one of our ratios above we're going to use, and we notice we're definitely going to be using the adjacent this time because we've been given the value of it, and we need to find x, so we're definitely going to be using the opposite as well because that's what we're looking for. And the adjacent and the opposite, the only one of the three of these that uses both the opposite and the adjacent is tan. So tan is the ratio we're going to be using. Tan 60 degrees is the angle we'll be using, is equal to, and what we're going to do is we're going to we know tan of this angle is equal to the opposite over the adjacent, so we're going to say is equal to x over 7. Again, we formed an equation that we can solve very easily. Multiply both sides by 7 or multiply across by 7. 7 tan 60 degrees is equal to x. So x is equal to whatever this turns out to be in our calculator. So putting it in, where are we? 7 tan, we're 60. Let's just see if this gives us an error without the... Oh, it allowed us to leave out the bracket that time, but best practice, leave the bracket in ordinarily. That works out to be approximately 12.12. 12.12. Whoops. So that's how we find the length of a side using trigonometry, given enough information, of course, to start with.